Today we're going to learn about copper mining. You've learned about ions and you've learned about dissolution, and now we can take that learning and start to apply it to some interesting and relevant concepts. So the main application of your learning in this topic is all about the environment. And you're going to learn about some big pollution problems and problems with industry, natural resources, as they relate to chemistry. So you're really going to use your understanding of chemistry to help you understand some environmental problems. So copper. If you take a look in your periodic table, you'll see copper is a transition metal. And if you remember learning about the differences in the different properties of metals, metalloids, and nonmetals, one thing you might remember is that metals are often good conductors of heat and electricity. And that certainly applies to copper. Copper is an excellent conductor. And that's one of the reasons we mine for it. So, you've probably heard of people mining for gold or silver because those are precious metals. They're worth a lot of money. We also have to mine for all kinds of other materials that we use in our daily life. So mining for copper is a pretty big industry in the United States, and a very, very important one because we consume a lot of copper. You might be wondering, okay, why do we consume so much copper? Well, I told you copper is an excellent conductor of heat and electricity, and so it turns out copper is very frequently used in computing. Right? So every time you take out your cell phone, take out an iPad, pull out your computer, start texting, start messaging, go on Facebook, you are using copper. You're taking advantage of the fact that we mine for and collect a lot of copper. So keep that in mind, especially as we start talking about all of the environmental impacts of copper mining. It's very easy to be critical of mining industries for the environmental damage they do, but remember, mining industries are able to mine for copper and make it profitable because we are buying products that are made with copper. So it's complicated. So let's talk about how copper is mined. Now, we don't just start digging and pull up copper metal. It's not that simple, although copper metal is what we want. So solid copper metal. That's the ultimate goal. That's what we use in computing. But copper is found in its ionic form. And it's an ionic solid. It's not found dissolved in water. Right? Sometimes it's found as copper hydroxide. Other times it's found as copper sulfate. So again, you're seeing these polyatomic ions show up, which is why you learned them. Right? It can show up in different forms. Right? And it shows up not as the pure ionic compound, but actually mixed in with a whole bunch of other things inside of a rock. And that rock is called ore. O-R-E. And that's not a word that's specific to copper. Ore is any type of rock that has some type of desired metal, mineral, or other resource embedded inside of it. So you might be realizing it's actually quite a process and a little bit complicated to extract copper from the ore, and that's the verb that we use. We talk about extracting copper. So we mine the ore, we pick out these huge pieces of rock from the ground, and there are many different types of ore that contain copper, and then we have to extract the copper from the ore. One very common copper ore, and this is the one we're going to use when we do a lab in class, is called malachite. So when you start crushing your malachite, when we're going to mine for copper, you're crushing a piece of rock that has, among other things, solid copper ions inside of it. So there are many different types of mines, and often when we think of mines, we think of people climbing deep down into tunnels in the ground. But copper is often mined in what are called open pit mines, which is exactly what it sounds like. And here is a photograph of an open pit mine in Arizona, right? And the thing about copper ores and a lot of other ores is that they're not found at the surface of the bedrock. You have to dig and excavate lots of waste rock. So it's kind of useless. We don't do anything with the waste rock before you hit the useful ore. But what do we do when we get the ore, right? You've already realized we're not digging up copper metal, we're really digging up this rock. So there's a whole process, and it's actually quite complicated. So I'm going to simplify a little bit. First, we have to crush the ore, right? We're going to kind of turn it into gravel or sand. And after we crush it, what we're left with, this sort of powdered, crumbled ore, those are called the tailings. And that's an important word to know. You're going to see it come up quite a lot when you start reading about mining and environmental pollution. So tailings are crushed pieces of ore. Nice and simple. But one problem is that tailings can be left inside of the mine. They don't always get all of the tailings out. But again, we don't have copper yet. We have tailings. So the next thing we need to do is we need to have a way to remove the copper ions from the tailings. Okay? And there are a number of different ways to do that, but usually we use some kind of chemical solvent. Solvent just means that it's a chemical that's going to dissolve the copper ions, right? And pull them out of the rock. And so again, the copper ions, let's say it's copper hydroxide, is going to go from being the solid ion to dissolved ions. Actually, this should be copper hydroxide 2. Sorry about that. Because copper is going to be a 2 positive ion when it forms copper hydroxide. Okay. So now we've got copper ions dissolved in some kind of liquid. Usually that liquid is sulfuric acid, which you've heard of many times before. We used it in the ester synthesis lab. And sulfuric acid, as you should remember from the ester synthesis lab, is toxic. So there is a problem right there. In order to pull the copper out from the tailings, we need to use a highly acidic, highly toxic substance. And that sulfuric acid, again, can leach into the environment. That means kind of travel through the groundwater, travel through soil, into the water table, into rivers, streams, lakes, places you don't want sulfuric acid. So leaching is a very bad thing. And what's the problem with sulfuric acid? Well, it can be damaging to aquatic life, and that includes plants, animals, shellfish, all sorts of life forms that live in the water. But there's another problem with sulfuric acid as well, and that's that these ores that we're extracting have all kinds of metals and minerals in them. So for example, malachite is a copper ore. But a copper ore could have other chemicals such as lead or arsenic. Now these are, if you haven't heard of them, again, highly, highly toxic chemicals. We do not want lead and arsenic anywhere in our soil or waterways. And one of the problems is that just like acid can pull the copper out of the ore, the acid can also pull these toxic chemicals out of the ore. So if we have tailings that are left in the mine, we have some sulfuric acid that leaches into the mine. The product of that is that the soil and the water near the mine can end up with contaminants such as sulfuric acid, which is really bad for the environment, lead, arsenic, and even just having copper ions in the environment is bad for aquatic life. It's considered a harmful substance. So here you have a photograph of the waste produced from a copper mine. And to give you a sense of the volume of waste that's generated in the mining process of copper, it's estimated that for the average mine, for every 1 ton of solid copper that we produce from the mine, we generate 99 tons of waste.